Welcome to Los Angeles Data Platform, not passive affiliated anymore. Session is Python in SQL Server 2017 and 2019. The presentation is by Chris Hyde. Sponsor our nonprofit, and you'll be able to follow us using the LA Data Platform hashtag and most social media platforms. I'm going to be posting link to our raffle, and we're going to be raffling every meeting. We're going to be raffling a T-shirt for the user group. I guess that is all. Chris, it's all yours.
Okay, wow, that was quick. Okay, can everyone see my slide deck now?
Yep.
Perfect. Okay, thanks everybody for joining me tonight. I love talking about how Python fits into SQL 2017 and 29, and also, since the last time I touched this slide, also in SQL Managed Instance in the Azure Cloud as well. So this is me. I'm based out of Albuquerque, New Mexico. It looks like I haven't updated this since Pass went away, but I do still run the user group out there. We are looking at having an in-person event in February if the vaccine gets distributed. So if you can't wait long enough for the next SQL Saturday LA in person, keep your fingers crossed and come out to Albuquerque in February. So February 22, of course, not 21. The most important things on the slide in the bottom right there is my Twitter handle. If you like the presentation, tweet about it. Let as many people know that it's good. If you don't like it so much, though, that's what the email's for. Let me know what I could do better next time. But seriously, if you have any questions afterwards, I know, when I go to a session, I always, think of some questions about 5 minutes after I log out. But feel free to use either of those two methods to, shoot me a question. But we're a pretty small group here today, so feel free to unmute yourself and just interrupt and ask if you have any questions. I think we can be pretty informal. We're not a huge group today, so and I think Steve will monitor the chat. Feel free to type in there as well if you're shy, and Steve will relay them to me if I don't see them right away. So here's what we're going to talk about this evening. There's a brief warning. I'll talk about how Python fits into the SQL Server ecosystem. And then usually when I give this talk, there's a pretty sizable number of people haven't had the chance to play with it yet. So I'll touch on the installation and configuration real quick for those folks. I'll go through the first demo of how we get data into and out of Python from SQL Server. So they're marketing, they use the term in-database analytics. I use air quotes around that. Because we are actually sending the data out of our database ecosystem, but from our querying purposes and all that, we never actually leave SQL. So it feels like we're never leaving the database environment. That may sound cryptic now, but when we see this demo, it'll make everything clearer. And then we'll spend that's maybe the first half of the presentation. The second half, we're going to look at two kind of in-depth real-world use cases where I've implemented this. It's going to be looking at my career as a consultant and primarily focusing in the healthcare industry. Well, before we start, I got to get this out of the way. There's going to be some math tonight. I hope you all were expecting that. I mean, I think most people by now know that Python's used for statistics and machine learning and those kind of things, so we can't really avoid the math issue. But I know a lot of you have probably been working all day, and the last thing you want is, more of this stuff. Well, sorry, I have to apologize. Hope you've all got some coffee like I do. and we'll get through it together. So this whole thing started kind of back in 2015 or so with a company called Revolution Analytics out of New Zealand. And they were working on a version of the R programming language that did a couple of things that base R doesn't do well. So it doesn't spill data to disk from RAM very well, and it doesn't do multi-threading too well. And actually, as it turns out, base Python doesn't do those things well either. But Microsoft at the time, they were wanting to get into, a lot of this analytics space, leaving the more traditional relational database, intact, but they know that they need to go further into the analytics space. And that's, historically and then continuing to be very much an open source proposition. So when they saw that Revolution, what they'd done with R, they were a natural fit to snap up. And so they put R in SQL 2016 as SQL Server R services, using the same connective tissue that we'll talk about for Python today. And then in 2017, they've added Python into the mix. So it was renamed as Machine Learning Services. And then in SQL Server 2019, you actually have Java available. And then this was also recently added to SQL Server managed instances in the cloud. So if you're using SQL 2017, 2019, or SQL MI in the cloud, you can do all the things that I'm going to show you today. If you're only on 2016, you can do all the same things. You'll just have to convert all my code back into R. And if you're on 2014 or before, well, I hope you can get upgraded pretty soon. We're going to talk about a particular distribution of Python called Anaconda. That's originally built by a company formerly known as Continuum Inc., but now Anaconda got so popular they rebranded as just Anaconda out of Austin. So it's a distribution of Python that is specifically focused on data science. And it's got a package and environment manager, so you can add new packages out there in the world, but it already comes with about 100 of the most popular data analysis and data science packages already pre-installed. So when you go through the installation process on your SQL Server, you're getting all of those 100 packages installed without you having to worry about that. Now, if you're using SQL 2017, it's Python version 3.5. If you're on SQL 2019 or on SQL Managed Instance, it's 3.7. Now, 3.8 is out there in the world, but you're not really missing much in going from 3.7 to 3.8. Even down to 3.5, there's really not a whole lot that you're missing, and you can definitely upgrade once you've got that in place. I don't know that it's something I'd necessarily recommend. It is a bit fiddly. So I think you're fine with just the base Python level that you're installing. And then one of the other tools that this comes with is this great tool called a Jupyter Notebook. Now we'll look at that in more detail in our second use case. But I'm expecting by now a lot of us have had a chance to look at notebooks, whether it's Jupyter Notebooks with Python or notebooks in Azure Databricks or even SQL Notebooks in Azure Data Studio. But just for those of you who haven't seen those, they're great tools that combine the code that you're running and the documentation about the code, but also the data that you're bringing in and saving, and any analysis, whether it's numerical analysis or whether it's graphical visual analysis, it all gets saved right in the same document. So you can pass it around your team, they can check your work, they can reproduce it. It's just a great tool. So if you haven't seen those, then you're in for a treat a little bit later on. So I mentioned Anaconda comes with about 100 different packages. So these are some of the most popular ones, and we'll be looking at 4 of these 5 tonight. So Numpy gives us multi-dimensional arrays. So base Python only has a single dimensional array, but if we want to take that out to multi-dimensions, i.e. like a 2-dimensional tabular sort of data like a table, we need to use Numpy. But really the package that gives us the most table-like abilities is this Pandas package. Now it's nothing to do with fuzzy and vicious bear-like animals. It stands for panel data. So it gives us an object called the data frame, which is, really the Python's closest thing to a table, and it gives us all the methods and functions needed to manipulate data in the tables. So all the things that we're used to doing in the SQL world, like grouping and summing, all those things, Pandas provides all that functionality. Now we'll look at SciPy tonight. That gives us scientific computing, statistical methods, probability, things like that. But we won't look at scikit-learn. That's sort of your entry point to machine learning in Python. There's just dozens of different algorithms that are available in scikit-learn. That would really be a whole other presentation for us to start diving into that. But if you're intrigued by what you're hearing tonight and you want to go down that next step, that'll be a great place for you to start. But we'll also look at Matplotlib. Yes.
Quick question.
Sure.
What happens if you install Anaconda separately? Would that interfere with what Microsoft installing with SQL Server?
It would. There is some interference, which as long as you work out the path variable, system variable, you can overcome pretty quickly.
Got it. Okay. Thank you.
So that's usually the best thing to do, is if you're installing it on somewhere that already has Python, just go in and tweak your path so that your default Python is the SQL version.
Okay.
Sorry, was there another question? I think
that's let's see. I might need to mute somebody, but again, I think we're good.
Okay, great. So we'll also talk about Matplotlib as well. That's a great library for us to create, pretty professional looking graphics and charts in just a few lines of code. So that's pretty handy as well. So I want to touch on the installation. I'm sorry, I knew there was something I forgot. I forgot to turn on my zooming.
Oh no.
There we go. So now, and this is a screenshot from 2017, but you'll see when you go through the installation, you'll have these options to do machine learning services in database. But then down below, there's also an option for machine learning server standalone. So everything we're going to do is that in database integration option. We're going to have a new stored procedure that we use called sp execute external script, and that allows us to kind of pass data back and forth from SQL to Python pretty seamlessly. So that's that in database stuff I was mentioning. Now the standalone, so that's there. Let's say you have a team of data scientists already in your shop and you want to set them up with a server using the extra stuff that Revolution built with R and the extensions they built in Python to do the spilling to disk and to do the multi-threading. Great, you can set up that server and let them have it. But for what we're going to look at today, you got to choose that the in-database option. And you can choose R and Python together. They work together perfectly fine. You may find you prefer one over the other, but pretty much up to a fairly high level. Anything you want to do with one, you can do with both.
Yes, there was a question if you can have both.
Yes. So yeah, they work just fine together.
And also if it's in process or standalone.
Okay, so I think I answered both of those questions while I was going through. So yeah, just make sure you choose the in database and not the standalone.
Perfect, thank you.
Now that will give you a brand new service called the Launchpad. Now I'll talk in more detail about where that comes in later, just wanted to point this out as part of the configuration that, hey, you'll see this new service and that's what it's related to. Oops. So we've got a couple things to talk about then after we've gone through the installation. So first off, even though this is available, we've done the install, it's not enabled by default in the system. So we are opening up a little bit of a security hole. Easy to patch, but if we're running malicious Python code, we're running it on our server. It could be accessing our operating system. So it's very similar to how we had to secure CLRs or common language runtimes when everyone was really excited about those. It's very, very similar in concept. We're running a different code language on our server and having that interaction with SQL. So because of that little hole, it's not enabled by default. So we have to run a quick script to enable it. And then we need to restart our SQL Server Launchpad service. And then everything will work. So like I said, even though it's installed, we have to manually turn it on. And then the other thing we want to do is we need to think about configuring our memory a little bit differently. So there were some dark days when I was a DBA. Apologies to any DBAs on the call. But I'd get a new server and I'd give 85–90% of the memory to SQL, let the operating system have the rest, and everybody's happy. But in this machine learning services world, any data that we're going to analyze or work on in Python, it's existing in a separate set of RAM outside the SQL Server buffer pool. So we need to take that into consideration. Now, the examples that I'm doing today, I'm really, taking a summary of data that's in my data warehouse and passing it over to Python. So they're a fairly small data sets, so no real worries there. But if in the real world we wanted to, do some heavy duty machine learning on hundreds of gigs worth of data, we'd really want to make sure we have all that memory set aside outside of the SQL Server buffer pool for us to really, leverage the performance here. So does that make sense to everyone?
Yes. Can you maybe compare it to XP command shell? Is it the same bad?
I'm sorry, could you say that again, please?
Yes, XP command shell.
So let's say I was using command shell to kind of call a Python script, or a batch file that's calling Python. I can do that, but then within that Python, I've got to use, say, an ODBC library or some other way of connecting to the database. What this in-database connectivity does is it handles that data transfer for us seamlessly and actually at a very low level, so very, very efficiently. I'll show you that in the diagram, but that's the the main reason here for us to have that that in-database integration and be running this all on the same server.
Got it. Thank you.
Right, so I mentioned the package manager, so that is called Conda. So if we want to add a new package, for example, PyODBC is one of the more common ODBC libraries, but that isn't one of the 100 packages that come with Anaconda. That's okay, we can just drop into a command prompt and do a conda install PyODBC. So for those of you who are familiar with classic Python, you can also use pip, the base pip, to do this as well. And there is actually a way of doing this without being connected to the internet as well. I know people see this and they're, they don't want to have the server connected to the internet to go out to the repositories. So there is a way for you to do that offline as well. But it's obviously much easier if you are connected for a little while to just do an install, or you can also use this to update to more current versions of some of the packages as well if you need to. So let's hop over into Management Studio for the first demo. And I'm contractually obligated to start out with a hello world. So that's what we've got here. So let me introduce you to SP execute external script. And that's the stored procedure that we're going to use to talk to our Python engine. And so we've got a number of different parameters that we pass into. Well, the @language parameter, that should be pretty obvious what we're using here. It's Python. And the @script, this is the Python code that we'll be running. So let's go ahead and kick this off. Now, this may take a couple of seconds because it's actually standing up our Python environment for us. So don't be alarmed that it's going to take 10 seconds or so to do a simple hello world. Now let's see, it should be a little quicker normally to bring up. There we go. But if I go ahead and run this again, you see it's instant. So it's just the first time we're setting up a Python instance, it may take a few seconds to get set up. And usually when I'm running this on most machines, I'm looking at about 8 seconds. But at the moment, I'm running an old laptop that's not real happy that I'm using Microsoft Teams. So probably most of the demos will be pretty slow tonight. But you see how as soon as we reran it, we've already got the Python instance running. It's pretty much seamless. All right, so let's do a little more than just write print statements. Let's take some data, and we're going to pull some data from a query. We're going to send that over to Python, and then we're going to get it straight back. So we're adding another parameter here, input data 1. And that parameter really is a query. So here I've got a tally table or a table of sequential numbers set up in my admin database. I'm just going to take the top 10 numbers from there. I'm going to send those over to Python. So the SQL engine runs whichever query is in here and then sends it into Python and puts it in this input data set variable in Python. Now I'm just setting an output data set equal to that. And then that data comes right back as the results of my SP execute external script. So there we go. Top 10 numbers sent to Python. I'm getting right back. But, this output data set and the input data set, these are defaults, and I don't necessarily always like them. What I prefer for the input data set is maybe something like my query. So when I'm using it in my Python code, I know, hey, this is the result set of my SQL query. So that's cool. I can change that default. I just have to add in another parameter to say, hey, that's the name of my input data set. And then, not surprisingly, I can do the same thing with the output data. So here I'm getting results. I'm going to call it results so that I know all the way through, hey, this is my result set. That's, however long my Python script is, it's this results data set that gets passed back. So now I've got that, and let's show that that's still working. It's one thing to point out here, we might see these _1s and think, well, that probably implies the existence of an _2, an _3, and so forth. But unfortunately, that's not the case. I don't know whether that's something they have planned for the future, and that's why they put that in there as sort of a pattern to be used later. But for right now, it really is one data set in and one data set out. So you really have to make sure you're doing your data manipulation to get your data into one data set before it goes into Python. And that, that's not too difficult really. SQL is a great engine, and it's probably going to do most of your data manipulation faster than Python would anyway. So let's do that in the database. Let's send the summarized data set over to Python. But as I said, just one data set in, one data set out.
Chris?
Yeah.
What happens if you have a syntax problem? So let's say you misspell something or you didn't type it correctly.
You will see that in a few more queries, actually.
Okay, no problem.
So before we get to that, I do want to show, okay, I mean, this is great. This is a one-line query, but how many of us only ever write one-line queries? Yeah, none of us. So one thing we might want to do is, as our query gets longer, let's break it out and put that in a variable. So I can have a more nicely formatted query here. And I've probably been developing that in another query window. And then when I'm ready to operationalize it, I come over here and I drop it into a variable. And then I just pass that variable into my input data. Similarly, this is a one-line Python statement, but that could get pretty long. So also I'm going to declare a PyScript variable and drop my Python code into that as well. And again, I've probably been developing that in Jupyter Notebook or PyCharm or Idle or any other Python IDE. And then when I'm ready to operationalize it, then I come into my SQL script and drop it in there. But so what that gives us is, no matter how complicated our query is or how much business logic we have to put into our Python code, we always have a nice clean procedure call. We don't have, I think we'll see the second demo, or the second use case rather, one of the queries that we use is about 150 lines. Now, I really wouldn't want to embed that into a procedure argument. That would look really messy. So I'd encourage everybody to just kind of use a pattern like this as much as possible. Like I said, it abstracts out your query and your code logic, gives you a nice clean procedure call. Much easier to debug when we do get to some of those errors. And there we go. See, it's all still working. So let's move on. Obviously, we're going to want to do more than just get the exact same set of data back. We want to perform some sort of analysis on the data. So let's start out with pretty much the simplest statistical analysis I can think of, which is just doing a standard deviation against our data. So rather than just passing back the query values that we send in, we're going to take the standard deviation and then we'll pass that right back. Let's close these. And if you've got quick eyes, you may know what's about to happen. And this is where we see what happens when we've got a Python error message. See, we've just got a huge wall of red text.
You have to do yours because I did mine this weekend or yesterday.
Sorry, was that a question? Okay, so anyway, you get this big wall of red text, and this is a good error message because it's got a scroll bar on the right. So yeah, it can be a bit daunting at first. The key is just to find the particular error that's being bubbled up from Python, and that's this piece here. So our standard deviation function isn't defined. Well, that's because it's not in base Python. It's part of the Numpy library. So we've got to bring in the Numpy library into our Python script in order to take the standard deviation. So here's the first piece of Python we're going to learn is how to bring in another library. So we're going to import our Numpy library that I mentioned earlier. And pretty much everywhere you see Numpy used in the wild, you'll see it abbreviated as NP. And this is just like using a table alias in SQL. So instead of table alias.column, you get package alias.method. Looks just the same. Okay, so now we've got that. But we've got another error here as well. If we scroll down and we find the right space, says our results should be of type pandas data frame. So we mentioned that the data frame is the table-like object within Python. And any data that we're sending into Python gets put into one of these data frames. But it also has to be in one of those data frames when it comes back out to SP execute external script. So even though in this case, the standard deviation just gives us a single floating point number, we need to have that in a table. And even though it's a table that's just one column wide by one row long, it still needs to be a table. So to do that, we'll need to also import the pandas library. And the conventional alias for that is PD. So one thing that we'll see, let me take this out of here, is pretty much any time in Python you see the name of a data type and empty parentheses, you're instantiating a new value of that. So if we did this, it's an empty data frame. And then if we have the result of our standard deviation calculation within those parentheses, that turns that automatically into a data frame. And as I said, this will be one column by one row at this point. And now that we've got that, then we can send that back successfully into SQL. So does this make sense to everyone, kind of how this works? That we're taking a SQL query, running that in SQL, getting the result set, sending that result set over to Python, running a set of Python code on that, and then sending that back into SQL. So we never actually left, our management studio window to do that. So that's where they say in database. All right, so let's look at a more interesting set of data here, and I'm going to go ahead and run this because this sometimes takes 40 seconds or so to bring in. So we're looking at the iris data set. It's one of the most famous data sets in data science. It's got the lengths and widths of petals and sepals, the different species of iris. And based on those numbers, you can very accurately classify what species an iris is from those measurements. So it's one of the first data sets that everybody starts with in machine learning. And it's part of this PyDataset package, more specifically this data library within the PyDataset package. But this also contains about 750 other data sets, not just the iris data set. So we're actually having to bring all of those in just to extract the iris data here. So that's why we're taking quite a few seconds here. So we're just going to pull that data in, turn it into a data frame, and kick it back out to SQL. Let's take a look at it. Oh, another error. Well, the good thing here is that this is only 2 lines of red text. And it's actually pointing us, specifically, actually, this is a SQL error, not a Python error. That's pointing us to this with result sets clause. We haven't looked at that yet. Now, this is something that was introduced in SQL 2012 to allow us to kind of redefine the data set that comes back from a stored procedure execution. But I never had to use it back then. I never had to use it till I started playing with the machine learning services, because everything that is being generated in Python is in Python data sets. And we need it to be in, Python data types. And we need it to be in SQL data types. So that's why we've got to use the with result sets clause. And all the examples we've done so far, we've just used this default 1 column. But actually, the iris data set has 5 different columns. So we've got to go ahead and specify those and give them column names in case we want to rename the values that come back from Python, and then also SQL data types and not Python data types. So that took about a minute before. This should probably take about a minute again. But So I'm showing you all this stuff, and it seems pretty simple now. It seems that I'm making pretty basic errors. But when I first started working with this stuff, nobody was really blogging about it yet. And it took me about, I would say, getting 6 to 8 hours to get these demos built and trying to figure out what I was doing wrong when I hit the error messages. So what I'm hoping to do with all these examples is to save everybody on this call 6 to 8 hours of their time and frustration when you all start playing with it yourselves. So if I can do that, for everybody on this call, we're looking at, a couple weeks worth of person time. So I think that's, pretty well worth my 60 minutes tonight for that. And there we go. We can see that we've got data coming back from, our iris data set. So here's what's going on behind the scenes. Over here on the left, we have our SQL Server process, and we call our SP execute external script. So SQL Server uses the Launchpad service to call the Python launcher, which then stands up both a new Python process, but also this thing on the right called the BXL server, which stands for Binary Exchange Language. So that is the transport mechanism of the data between SQL and Python, and we're doing it right at the TCP/IP level. So no need to go through ODBC libraries or any code like that. Just straight send it through TCP/IP. That's very, very efficient. So this is really kind of the reason why you'd put this on your, say, your data warehouse box, is you can get the data back and forth much more efficiently than, say, doing ODBC. And it also allows us to, do some things like we'll see in our use cases coming up, where we're going to, do some, let's say, I'll call it some of the data science secret sauce or special sauce. We'll put that into our existing on-premises SQL stack processes and actually provide a lot of value to our end users. So I mentioned I'd talk about some of my consulting activity. So I don't want to talk about the companies that I've worked with specifically. I don't want to name the ones I could name, or shame the one in particular I could shame. So instead, I want to introduce you all to my fictional hospital, where all the doctors magically look like famous actors. And so we've got a couple of problems here at my fictional hospital. So let's tackle the first one right off the bat. So what I want to know is, and this is going to be difficult doing virtually, but put everybody on the honor system here. So if you're a report writer right now, put your hand up. If you've been a report writer in the past, put your hand up. If you've even written a production report at any point in your career, put your hand up. Okay, now leave your hand up if a report that you've written and pushed out to production has ever caused panic. Yeah, it's probably everybody's keeping their hands up. And it's the same thing here at my fictional hospital. So we've got an SSRS report out here. So let me jump over to our reporting services. And this is just a simple summary of our daily charges for our organization. So I could limit this to primary care or specialty care. I could limit it to the cardiology department or to peds. I could even limit it just to bones or just a Dr. Quinn medicine woman. But instead, we'll just run it for all the different values, and we'll look back at the last 30 days of charges for our organization. And what we will see here in a second when this loads is that our charges for yesterday took a huge drop from Monday's charges and are pretty low across the board. So what happens is our clinic managers see this and they freak out, they panic, and they put in an urgent ticket or whatever whatever indication of panic happens in your organization. But is there anything really to worry about here? No, not at all, actually. I probably wouldn't be showing this if there was. So here's how I know there's not a problem. I've brought this data into, say the last 180 days worth of charges. I brought this into Python and done a quick histogram on it. And what I see is it follows this, this classical bell curve, what we call the normal standard distribution. And I can infer a couple of things from this. So first thing I can infer is this is just normal, regular day-to-day variation, because it's just, a single bell curve. It's not, like a dromedary going up and down or multiple humps. So, I know this is just, probably nothing crazy going on, just normal day-to-day variation. But what I also can infer is the magnitude of that variation. So here's some of the math that I warned you about from the beginning. And you may remember this from when you first took statistics. But let's look at the graph in the bottom left corner here. What it's saying is that when our data fits this normal standard distribution, 95% of it will fall within +2 and -2 standard deviations from the mean. And now also it's symmetrical. So the 5% that doesn't fall within there is really 2.5% on each side, or really 1 day out of 40. So 1 day out of 40, we're over +2 standard deviations. 1 day out of 40, we're a little below -2 standard deviations. So what I can do is if I can calculate those points, that +2 and the -2 standard deviation, and then put those points on the graph as horizontal lines. So it's an old technique from my manufacturing days called control lines. It's how we knew whether a machine was about to start producing bad parts or not. Or if I put those control lines in there, then our clinic managers can look at that and say, yeah, we're a little bit low, but we're still within the normal range of day-to-day variation. So, I could get pretty complicated with this, but I think I'm fine just sticking with the +/-2 standard deviations for now. So all I have to do is code this in T-SQL. Okay, well, that doesn't seem like very much fun. But we already know that Python is really good at doing statistics for us. So let's leverage some of that in database integration to get Python to do our statistics for us. So let's hop back into Management Studio here. And so for some context, this is the stored procedure code that provides the data to the existing report. So these are the 4 parameters that we saw. And this is a pretty standard pattern. So we're summing up one of the measures that's in our fact table. And then we're joining in the dimension tables so that we can filter the members of those dimension tables based on the parameters that we've passed in. So if you've written a report, especially if you've written a report query against a data warehouse, you've probably written something that looks almost exactly like this. And so we're going to use this as the basis for a second stored procedure that gives us just the statistics. Now, note that we're using 3 of the same 4 parameters. We're not using the number of days to look back because our clinic managers might decide they just want to look at the last 7 days worth of charges. And that's not really enough to make any kind of strong statistical assumption. It's just too small of a sample size. So instead, we're going to hard code to look at the same 180 days worth of statistics that we saw in our histogram. But so this next part of the pattern is the same. Now we're going to sum up one of the measures in our fact table, join in our dimensions, and then filter the members of those dimensions based on the parameters. So you may have noticed one extra thing here. We need to cast this value as a float, because we need to put it into a data type that Python understands. And Python does not understand SQL fixed precision numeric types. So this is probably a decimal 12,2 in my database. But if I send that into Python, Python is going to barf and say it doesn't understand that data type. So it feels a bit weird to us to use something that's a little less precise, but it's what we have to do to get Python to understand the data. And in fact, any data type that is based on those fixed precision numeric types. So obviously money is the same way, but also like small date time 2 is actually based on those fixed precision numerics. So you can't use that to send a data over to Python. So you may find a few of these wrinkles as you're using this integration, and they can be kind of a bear to figure out if you haven't seen them before. Now, what I'm going to do here is I'm going to sum up these charges. I'm going to throw them into a temp table. Now, I would not throw these into a temp table in production. I'm really just doing this so that I can, fit my input query on one page for you all for demo purposes. So, I mean, this is about a 40, 50 line SQL statement. In reality, I'd put all of that into my input query here and go from there. But just for demo purposes, I wanted to be able to show you all some that fits on the screen all at one time. So I hope that's clear to everybody that this is kind of a do as I say, not as I'm showing you right now. But so it does make it a little easier for me to point out a couple things. So first off, I'm filtering out Saturdays and Sundays. So why am I doing that? Well, I'm doing that because I told a little white lie. I said this was my fictional hospital, but it's really my fictional ambulatory clinic. But that sounds kind of clunky and it doesn't really fit in the header up here. But because we're an ambulatory clinic or an outpatient clinic, these gaps here, that's Sunday. We're not open on Sundays. The very small blue bars next to them, well, that's our Saturday, where the only thing we have open is our urgent care clinics. So if I included those, then all our statistics would say, our mean would be running right through here at about 350. And well, that's great. We're above the mean on 100% of our work. Oh, okay. So we would notice that, pretty obviously, right? What we might not notice right away is this other bit. By the same token, we weren't open on Christmas Day, which I think was a Friday this past year. Within our last 180 days that we're basing the statistics on, we weren't open on Christmas Day, so we've got to filter that out as well. So that would only be a couple of %, not enough to notice visually, but enough to, give us bad results. So I show this to make a point that this is really where the stuff starts becoming data science. So there's a famous diagram by a guy named Drew Conway where he talks about data science being the intersection of hacking skills and statistical knowledge, and then substantive expertise, he calls it. Other people call it domain knowledge, but it's really the knowledge about the business. So you may have the hacking skills, so that's the Python coding, the SQL querying. You may have the statistical knowledge to know that, hey, our data fits a bell curve, and here's what the implications of that are. But without the actual knowledge about the business to properly apply those other two things, you're going to get some bad results. So it's really where all three of those pieces intersect. That's really the point at which things start becoming data science. So it's not just about the coding, it's not just about the math, it's also about the business. So you really have to know all three. So here's our data set that query that we're running to get our data set to send over to Python. And then here's our Python script. But we notice something right away here. Now, as you look through this code, you can see I'm pretty fastidious about my spacing in my tabs. Everything's tabbed over from the begin. Very particular, lots of white space, very readable. But Python doesn't agree with that. This, at least the SQL engine, ignores white space, right? If you have a while loop in T-SQL, you have your condition, and then everything you're iterating through is between a begin and an end. So that's how the SQL engine knows this is the block that I'm iterating through. Well, Python doesn't have that begin and the end construct. It uses white space. It uses a tab. So, we'd have our conditional, and then tabbed over, we would have the block that we're running through. So that white space is actually meaningful to Python. So if Python sees a tab that it's not expecting, so something like this, Python sees this tab and says, hey, that's an unexpected character, and errors out. So that's why, this block looks a little bit different and is left indented all the way. It's because that's what it has to be for Python to understand it. Now note that, in our little list here, things are tabbed over, but Python knows to expect that based on the comma. So it's, Python's expecting this space here, where it wouldn't be expecting a space here. And so this is really a pretty simple query. This is just really 5 lines of code, to bring back the standard deviation. And just 2 of those are importing the libraries, as we've seen before. Now we're going to create a list here. And a list is a collection of data delineated by our square brackets. And it's just 4 data points here. It's the mean, the standard deviation, the mean +2, and the mean -2. Okay, but we know from our previous demo, we can't just send any old Python structure back to our SP execute external script. We've got to send back a data frame. So let's put my list, let's turn it into a data frame. Great. Except at this point, it's treated this list like a column. So our data frame is really 1 column wide and 4 rows long. But what we really want for our SSRS report is to have 1 row with 4 different columns, 1 column for each value. So to do that, we've got to do an unpivot. So how many of you have written a pivot or an unpivot in SQL? Well, don't you wish it was as simple as saying .t? Because all we're doing in this case, we're not doing any summations or splitting things up. We're just changing the axes. We're transposing the axes. So this .t does a transposition. It switches the x and the y axes. And so now our data frame is going to be what we need, which is 1 row with 4 different columns. And then we've got...
But this is not just a pivot, that's basically a dynamic pivot.
Yeah, so this is just a simple unpivot with no summations, just really changing our axes.
Got it. I'm just saying that pivot on pivot is complicated, but dynamic is even more complicated. Now this is just .t, and that's all.
Yeah. This is my favorite 2 characters of the whole presentation right there is that .t. All right, so we've got a nice clean procedure call. So we're going to drop that into a second version of our report where we put those control lines on there. And let's run it for the same values here. Give it a couple seconds. Oh, my machine is not happy with me this evening. It's time for an upgrade. Okay. So here we go. We can see that, yeah, we were a little bit low yesterday, but we're well within the normal range of day-to-day variation. So our our end users, they don't care about bell curves or any of that stuff. They just want to know, tell me when it's good, tell me when it's bad. And that's what we've been able to do for them in, excuse me, in a tool that they were already used to using. They're already used to seeing SSRS reports. We just used that integration to add a little bit of extra value in here. So one question that comes up is, well, why do we even have the green line? Wouldn't it be great if our charges were way up by the title? But it really wouldn't. You can't have this both ways. I mean, that histogram is symmetrical for a reason. So if we were way up here and we didn't have a good reason for it, I mean, we might have a good reason, like we hired a bunch of new doctors or opened up a new clinic, then yeah, that's going to change our statistics. But otherwise, that's the point at which I would panic, because maybe we're duplicating our data somewhere, or I've got a Cartesian in my report query or something. So that's really the panic point for me. And so just one other piece here, another white lie. I implied that we would need to code this monster in T-SQL. Well, T-SQL does have a nice stdev function already. But I just wanted to get us started thinking about the kind of patterns here, because the second case here I'm about to talk about, there was no way we could code that in T-SQL. So let's talk about our second problem, which at my fictional ambulatory clinic, it's our patients. More specifically, it's that sometimes they just don't show up. So what's the magnitude of that problem? Well, as we'll see on the report, Bones, he's a cardiologist. Now, you don't miss too many of your cardiology appointments, right? So only 10% of his patients no-show. But Dr. Quinn Medicine Woman's a family GP. Nearly 25% of her 32 patients a day no-show. I mean, I've been guilty of this myself occasionally, right? You make an appointment because you're sick, but you can't get in for a couple days. And then by the day of your appointment, you're feeling better and you forget to call and cancel. Yeah, I know I've done that myself. But what that causes is that, 8 of these 32 patients at 15 minutes a pop don't show up. So she's idle for 2 hours, not making money for herself, not making money for the organization. So, okay, no problem. Let's just overbook an extra 8 patients a day, right? Because we know 8 aren't going to show up. Let's, book an extra 8. Well, except what happens sometimes is that 30 out of 32, 30 of her 32 original patients show up, but we booked an extra 8. Now we've got 6 patients too many. And at 15 minutes per, that last patient has been sitting around in our waiting room for 90 minutes before being seen. So they never want to come back to our practice. So, we were trying to maximize our revenue. We end up minimizing it long term because we upset so many of our patients. So really what we need to do is find the magic point to where we can overbook without overbooking. And so this is, common in other industries, like the hotel industry. For example, they overbook some of their rooms in most hotels, the airline industry, but, we're not like, that famous United Airlines incident from a couple years ago. We can't just beat passengers on the head and drag them out of the plane or drag them out of the waiting room if we've overbooked too many, if we've sold too many seats. So, we can't do that. So let's find, that magic spot. And so to do that, we're going to use this tool called the Galton Board. Now, you may have seen this in a science museum or in the Plinko game on Price is Right. But you've got a series of pegs set out horizontally in rows, and then you drop a ball in, and at each peg that it hits, it's got a 50% chance of going left, 50% going right. So the two options, it gives us the term binomial for the type of distribution that is created when you send enough balls through enough rows of pegs. And so this mimics the same thing that we've got going on, the left-right paradigm. that's just like the patient shows up or the patient doesn't show up. So it's the same kind of math. It leaves us with a binomial distribution. So Pascal figured out all the math for this back in the 17th century. But you know what? It's more fun just to see it in action. So let me switch over to the video here, and hopefully the audio comes through okay for you all. And that should have started. There we go. Well, I'm sorry about that, everyone, but I encourage you all to, Google for Galton Board videos and just watch them in action. They're, pretty mesmerizing as we go through. So actually, let's jump in and let's look at some of the math using one of these Jupyter notebooks that I talked about before. So I mentioned these before, so you can see we've got a lot of different cells of code. Okay, so here's the notebook, and you can see as we're going through, we have a number of different cells of code. As we start running these, we'll generate the data, and we'll be able to save that data when we save the document. And so I could share this whole thing with other people on my team. So let's just start out. These are the Python libraries that we're going to use. So let's go ahead and run this. And then, I know this is a binomial distribution. Maybe I don't remember off the bat, exactly which methods. So let's look at the documentation. Let's look at the help. And I can see. Yeah. As I'm looking down, what's interesting, it looks like a lot of these methods actually have the same arguments or the same subsets of arguments. So we'll look at 4 here. We'll look at the RVS method, which is the top one there. And that enables us to generate data that fits that binomial distribution. And then we'll look at the second one down, which is the PMF, the probability mass function. And so that gives us the exact chance of, so let's say Dr. McCoy's patients, we saw they show up 90% of the time, so P will be 0.9. And here's 16 patients a day, N equals 16. So let's say, what is the exact chance that 15 out of his 16 patients show up? K equals 15. The probability mass function will give us that percentage chance. And then also a couple down, we have the cumulative distribution function, which instead of exactly 15 gives us 15 or fewer. So they're related. But then further down even more, we have this percent point function. So this is really the magic part for us. What we're going to say as a business is we're going to overbook. And it's okay if we overbook to the point at which, let's say 10% of the days, we have 1 or 2 people extra sitting around in the waiting room. That's not so bad. That's not going to upset them so much that they won't come back to the business. So let's find the 90th percentile of the way along that binomial distribution. So, given Dr. McCoy's 90%, P equals 0.9. Given that he sees 16 patients a day, what is the 90th percentile, or the Q equals 0.9 of the way along that distribution? And so that seems a little esoteric now, but I think when I show it to you kind of graphically, it'll make more sense here in a second. So let's use this RVS method to generate some data. And so the other classic example of this is just flipping a coin. We've got 2 options, right? Heads or tails. So let's, take one coin and let's flip it 5 times and count the number of heads. So a head will be 1. That's the outcome we want. And the tails, the outcome we don't want, will be a 0. So this will be analogous for us later on that the outcome we want, the patient shows up, will be a 1. The outcome we don't, the patient doesn't show, is a 0. And this is a fair coin, so it's a 50-50 heads or tails. Let's go ahead and run this. Okay, 3 heads, 2 tails. Run it again, another 3 heads. Now 2 heads, 3 tails this time. But you know what? Let's just do this more. Instead of 1 coin, let's take 10 coins and add up the number of heads we get. And instead of doing that 5 times, let's do it 20 times. You know what? Let's just do it 1,000 times. And so we see, as we'd expect, a whole lot of 5s and quite a few 4s and 6s. You know, 1 lonely 10, not seeing, 1 0. So we can probably guess intuitively this makes sense to us. Well, let's see what that looks like in a histogram. So here's one of those, just a few lines of code. Gives us a pretty nice looking histogram, right? And we can see, yeah, this is looks like the Galton board. The middle is 5. That's the mean. It's also the median because we're symmetrical, and it's the mode because it happens the most often. So okay, that looks like we'd expect it to. But if our patients only show up 50% of the time, we're not going to be in business very long, right? So let's bump up that probability to 70%. So now it's an unfair coin. And we can see how we've skewed quite a way to the right. But with Dr. McCoy, it's even more extreme. We saw that 90% of his patients show up. So I think it was 10.49% don't show. So it's just a little under 90% of the time his patients show up. And he sees 16 patients a day. So what do 10,000 days in his career look like? Oh, there we see even more skewed to the right. And so, we said it was okay for us in our business to have 1 or 2 extra patients 10% of the time, right? But if we look at this, all of Dr. McCoy's patients show up about 1 out of every 6 days, which is more often than 1 out of every 10. So we really can't overbook for Dr. McCoy. We're kind of seeing that graphically. Let's take a look at the numerics and see if that proves out. So here's our probability mass function. So this is what percentage of the time do 15 out of his 16 patients show up? It's about 32%. Does that jive with the graph here? Looks kind of like it. Okay, well, let's use the range. Let's look at all of his different percentages for all those different options all together. So here we are. This is top left is going to be 16 out of 16. That's nearly 17%. 15 out of 16, we've seen 32, about 28% for 14 out of 16. But we're seeing numerically, again, that's 17%. That's more than the 1 out of every 10. So we really can't overbook for Dr. McCoy. But it was at this point that things didn't really jive with what I thought I knew about our business. And really, everybody shows up, more than 1 out of every 6 days. Maybe I did something wrong. So what I needed is a way to check my math, basically. And so I'm not a PhD statistician. I'm never going to be that level of data scientist, but I did play a lot of Dungeons and Dragons as a kid, which is the next best thing. And because of that, I really got a good working knowledge of basic statistics and probabilities. And I know that with these discrete events, and when I say discrete events, what I mean is whether or not Mr. Smith shows up for his 10 o'clock, there's no bearing on whether Mrs. Torres shows up for her 10:30. They're completely independent like that. So when these events are discrete, I can multiply that percentage chance, that 90% by itself, 16 times. And yeah, it really is that almost 17%. So yeah, so I'm doing this right. And I'm doing this to make a couple of points. So the first point is, when this machine learning services got added to SQL, the marketing spiel kind of treated it as a magic bullet. Like, you don't need to know any math to do machine learning type stuff. But I'm here to tell you that's not really the case. I mean, you don't need to know a great deal, but you do need to know enough to, when you get a result that doesn't look right to you, can you figure out a way to reproduce that result another way? Does it fit mathematically? Right, so to check that you're doing things right. So it's really good to have enough of a good grasp of math to be able to do that kind of stuff. So the second point is that you really should be playing more D&D. It's going to be super helpful for your data careers going forward. All right, so let's move on. Let's look at the cumulative distribution. So instead of exactly 13, which we saw here would be about 15%, what's the probability that it's 13 or fewer? That's only 23%. So the sum of 15 all the way down to 0, is still only about 23%. But there's not a way to use this function right off the bat to say more than 13. We just have to know that more than 13 is the opposite of 13 or fewer, so that we can subtract that from 1. And that's 14, 15, and 16. The cumulative probability is about 77%. But it's really this percent point function that we're really interested in. So that's going to give us the 90th percentile of the way along that distribution. So in this case, the distribution of 90% and 16 patients a day. So the 90th percentile of the way along that distribution. And yep, it's 16 out of 16. So again, we can't overbook for Dr. McCoy, because if we did, if we allowed even one overbooking slot for him, then we'd have more patients than slots on nearly 17% of our days, or more than our 10% threshold. But let's look at family medicine instead. So if we look at her complete percentages, now remember Dr. Quinn's patients no-showed just a little more than 25% of the time, and she sees 32 patients a day. So this is 32 out of 32. And that's less than 1/100th of 1% of the time. This is 31 out of 32, less than 1/10 of a percent of the time. So how far do we have to go down here to get into our 10th percentile? Is it in here? Is it in here? Well, let's see what it looks like graphically. Maybe that'll be a clue. Okay, well that's looking much more towards the the normal binomial setup, the what we saw on the Galton board, but we still can't quite tell, is that 90th percentile in this bar? Maybe it's in this bar. So let's use that percent point function to find the 90th percentile of the way along this graph. And it's at 27. So yep, it's in this bar. So what we can do is we can fairly safely, 90% of the time, we can overbook 5 slots for Dr. Quinn every day. And if we fill all 5 overbooking slots every day, we'll only have, slightly too many patients on 10% or less of the days. So all that is great, but our clinic managers fell asleep ages ago. They just want, tell me how many people I need to overbook. So let's put all that math that we just learned, and let's create a stored procedure for it using our in-database integration. So you've already seen, these 3 parameters. We'll let our clinic managers run it for any 2 date ranges. Let's say they want to run it for all the appointments next week. We'll even let them customize that 90th percentile. Maybe they want to drop that down to 0.8, chase a little more revenue at the cost of upsetting some more patients, but we'll let them manage their own clinic that way. So we'll allow them to customize it that way. No, we're still using the same 180 days worth of statistics. In this part of the pattern we've seen before, we're summing up one of the measures, in this case our appointment count from our appointments fact table, joining in our dimension tables so we can properly filter the members of those dimensions based on the parameters we're passing in. And then we're going to figure out our no-show rate, just the number of no-shows divided by the number of appointments. But what we've seen before is, it's not the no-show rate that we're using for all our calculations. It's the show-up rate, or 1 minus the no-show rate. And so again, I'm going to throw this into a temp table, just a physical one. I wouldn't do this in production. I'd put all this in my input query, just, going ahead and showing you all, that, for sake of ease, for sake of a nice looking query here. Note I'm casting as my floats. But, all that complicated math that we looked at in our Jupyter notebook, we can do that in 8 lines of code in Python. 7 lines of code, 3 of which are just making sure we've got the right libraries. So we bring this into our myQuery data frame, and we're going to add a column here, an empty column called expected appointments. Then we're going to fill it with the results of our %point function based on our customizable threshold, based on our historical no-show rate, and based on how many patients we actually have for that doctor for that day. And then we will calculate the number of overbooking slots allowed. So for Dr. Quinn, we saw it was not the 27 that we want to know. It's the 5. It's the difference of her 32 patients and the number that will show up to give us the number of overbooking slots. And then we also want to calculate our total free slots. So, Dr. Quinn isn't always going to be booked every day. She might only have, I don't know, let's say 28 for 32 booked. And our %point function for 28 probably is going to return about 24. So we've got 4 overbooking slots, but then we've got 4 slots that we never even booked in the first place. So it's not the 4 people we've got to get, and it's the 8. So given all that, now we've got a simple report. And again, this is a lot of complicated math and logic, but we're just doing it right in tools that we're already used to using. Reporting services and then stored procedures. So let's look at this for appointments next week. Leave the same threshold. Let's take a few seconds to come up here. And so all this, this data science secret sauce, as I call it, we didn't need to be full-blown, data scientists to use it. We just needed to understand enough about statistics and know how to integrate that into our in-database integration, to give us some, stuff that's able to drive revenue, pretty strongly. And so we see Dr. McCoy on Monday. He's got 12 patients scheduled, but we're expecting all 12 to show up, so no overbooking slots allowed. But because he's got 16 patients a day, that's still 4 slots, that were never open in the first place. So down to Dr. Quinn, well, that's exactly the example I mentioned earlier. She's got 28 patients, so we expect 24 to come in. So that's 4 overbooking slots, but plus the 4, or the 32 minus 28, the 4 that never got booked in the first place. So our clinic managers know, hey, they've got to get on the phone and get 8 new patients in the door for Monday. So yeah, pretty powerful stuff without having to, go out and, buy any complicated third-party packages, just with a little bit of statistics knowledge and knowledge of how to integrate Python into our system. We're really able to drive a good revenue increase here. So that's really it. I know I'm way over on my time. I just wanted to leave you all with a couple of links. So I will, I'm not sure if Steve, I'm not sure if you have a place that you can share this presentation. I think you're gonna save the video, but if you need a place to put the slide deck and all the code, I can send that to you. But also anybody who's interested, they can go to my GitHub here, Dr. Jekyll 325, and find this in the presentations. And so that's got all the code, not just the Python code, but the SQL code to generate all the data behind the scenes. so that if you run through all the steps, you can actually reproduce everything that I've shown you for you today. And then if you want to get into the next step, Microsoft has got a couple of really good tutorials for this stuff. I'd encourage you to go through. They've also got pretty much the same tutorial here. I think this is maximizing revenues for a taxi cab company. They've got an R version of this as well. So if you've heard about Python, you've heard about R, you're not sure which one you'd rather go into, you can actually try out both, the same thing in both tutorials. And then this last link, I don't think Microsoft has this professional program with edX anymore. But this is here as an example of all the MOOCs, the massive open online courses that are really into data science and statistics, and all this information about how to do this stuff is out there freely available, or in some cases for a very small fee to get a certificate. It's a really good way to get started with the learning, but also kind of show your boss or your next boss that you understand how to do this stuff. So we're living in a great time where all these tools and techniques have really been democratized. You've heard it called the democratization of data science, but it makes a lot of all these complicated techniques really available to start learning without having to go through a graduate level statistics program. So I'd encourage you all to go to those MOOCs, whether it's edX or Coursera or any of the others that are out there, and start trying your hand at some of this stuff. So that's it for me. Are there any questions that came through that I missed?
No.
All right. Anybody have any last questions that they're thinking of, or does everyone want to get straight to the raffle for the t-shirts?
Chris, can you hear me?
Yep. Hi.
Quick question, and I honestly don't know if there's really a use case for it, but can you do functions in there? Like inside SQL Server in Python?
You sure can. So depending on what what type of function, whether if it's a SQL function, you're going to want to incorporate that into your input query code and get the results of the function before you pass it over to Python. But anything that you can do in Python, including defining new functions and calling those functions, you can put those in your Python script just fine.
Okay, as long as you keep the format, right, the spacing as you said and everything.
That's right.
Okay, thank
you. And if you have something if you have some really complicated logic, for example, what you can do is, and I think Dwayne's asking this as well, you can actually create your own libraries and you can save them to the folder where all the binaries go. And let me show an example here. So this is just my laptop, so I've got everything on my C drive. So here is my, I think this is a SQL 2017, so SQL 14 here, Python services. And let's see, I want to say it's library bin. No, oh, I knew where this was the other day. Library include. Oh man, Yep, there we go. So under your SQL Server folder, this is my instance folder. That's just my default here, the default instance, Python services, and then scripts.
Okay, perfect. Hold it for 1 second. I'm gonna actually do a screenshot so that way I won't forget.
I'll drop that into the comments here.
Okay.
Into the chat.
Perfect.
And so this will look different for you depending on where you put your SQL install. But it's the
So can
the SQL folder, and then the instance folder, and then Python_services, and then \scripts.
so can you
Right.
manage this environment?
So that's what the Conda package manager is intended to do for for getting
Right,
new
but
packages that are out there.
But it's generally managing the packages under its own install directory, right? The environments.
That's
So
right.
can you point like Anaconda at this folder underneath SQL and
So
manage environments there and install packages and all that? How do you install new packages or update?
So let's go back to the
And then you probably have to worry about breaking the environment, right?
If you've gone through the install of SQL, you've gone through the install of the in-database integration through the SQL install. That installs the Python instance and all the Anaconda packages. And then you use the Conda package manager to install new ones or update new ones. But this is much more manual than you're used to doing for like database hotfixes. So I've definitely seen things that will break from one version of a package to another, or one version of a library to another. So if you're planning on doing, like upgrading a package because you found out about a new feature that a particular library has, you're really going to want to test it in a test system first, and do some regression testing on your code.
I've always kind of had major failure trying when I've had different installs of Python. So even with just straight Anaconda, I know there was a problem recently with a version a few back where it wasn't able to update itself. So I had to do a total uninstall and reinstall. But whenever I pull up a command prompt and start using Conda, how does that deal? How do I know which Conda am I dealing with? If I've installed it this way and SQL Server's installing Conda, but I have Anaconda installed proper, it's got its whole different folder structure with its different environments. And I've thought when I pull up the command prompt and say Conda, I'm talking to the Anaconda Conda, not the SQL Conda. You see what I'm saying? How do you know what path you're?
Well, so I guess, two things there. One thing, the SQL Server Conda is always going to go in the same folder structure that I just mentioned. So it's your SQL Server development, or your SQL Server deployment, your program files, your SQL Server, your instance, and then Python_services.
Right.
So that's one answer. That's how you're in the right one. I mean, the other answer is if you're really doing this on your server, don't do the standalone Anaconda install.
Anaconda.
Ever.
Right, but I'm on my development box, and now I'm starting to question: if you install both of them, which one are you using if you're not necessarily in the Anaconda environment? And you're playing around with Conda, how do you know which one you're affecting? Right? It has to do with your system paths, right? Whichever one is first in the pathing. So I can imagine that. Unfortunately,
Yeah.
every time I've been in a situation where I've had Python installed in more than one location, it's caused massive confusion for me. And I haven't been able to understand what's going on, and I just blow all of it away except one.
Yeah, I've had the same problem, but have managed it by manipulating the path variable.
Okay.
So yeah, so that's really the best answer I can give you. Sorry.
No worries. Thank you. Great session.
Thanks. Oh, thank you. Any other questions?
Let's give it a minute for people to wake up with questions after Python.
Yep, and it looks like Thomas dropped the GitHub link right in the chat, so that's good. Anybody? I think Steve, you were asking to, not Rajna, Johnson was asking for getting a hold of the slides and code. Yeah, you can get versions of this by following that link.
I'm assuming, Chris, you can send me either the PowerPoint or probably PowerPoint is on GitHub as well, and I can just send an email to everyone that attended, actually maybe did not attend, and this way they will get the link to GitHub plus PowerPoint as well.
Yep. And yeah, and in fact, if I look at the GitHub, these old PowerPoints are pretty similar. There's very few changes, and then all the code is the same. With I think the hello world is the only difference. So even though these are pretty old files, they'll all have exactly the same info.
On a slightly separate topic, are you still playing with RStudio or no?
Not so much. Not since I started working with Python. I've left R mostly behind.
Got it. And is it fair to assume that Python is the way to go?
I think so. It depends somewhat on your industry. If you're in academics, then R is still the number one there. But broadly in industry, Python has really taken the lead, because companies use Python for other things, not just data science. They use it for scripting, or even simple websites or simple front ends. So they were like, hey, we can just have one tool, one IDE to use all these things. We don't use Python for one thing and R for the others. So yeah, definitely, I think it was about 2018 where we saw Python kind of overtook R in terms of usage from most of the KD Nuggets surveys. But for the most part, the similar functionality for both R and Python exists. If you're in the academic world, R is probably the best one for you to learn. If you're in other industries, Python is particularly good. You can use Python in Databricks as well. I guess you can use R in Databricks. I just always see people using PySpark, so it's good to learn Python for Databricks as well.
And Dwayne is sending a link to some index for languages, and I guess Python is somewhere.
Oh, number one language of, or their programming language of 2020. Now, of course, this is sort of the wider everything
Visual
we'll talk
Basic.
about. Yeah, let's see. Let's brings up one of the. Yes, this is a little older of a poll. You can see that our kind of from 27 to 2019 lost a little bit of market share and Python increased. So I think that's where things are generally going. But there's also a lot of overlap. You see, these percentages are way more than 100 because people are using more than one tool.
Yeah, and this is, and what you're showing is basically specific to data science.
Yeah.
As opposed to just general scripting language.
Yeah. Yeah, so this is general programming languages, and this is specifically analytics and data science. And note everybody's favorite Excel is still way, way up there.
I'm sure Excel is going to show up at the top databases as well.
Yeah, that's the case.
Wonderful session. Thank you for spending the time and sharing your knowledge.
All right. Good night, everyone.
Good night. Bye-bye.
Night. Bye.